Hmm. Good morning. Good morning. Welcome to week 8. I hope it's week 8. Yeah, it's week 8. Is it week 8 or 9? Hang on. There's 2 more weeks in November,
I think
and
it's
then we only have. Hmm?
I think it's 8.
Oh, how is that possible? Because we have only 2 more weeks in November, and then 2 more weeks in December, and we're supposed to end by the 15th of December. So that's 15 days, 2 weeks in December. So 9, 10, 11, 12. That's 4 weeks. Oh, maybe those 2 extra days in, after 28th, 29, 30. Oh, it works out. Oh, today's Tuesday. Plus, all right, 4 days. All right, okay. So yeah, it is week 8. Anyway, all right, okay. So my plan for, yes, please do switch on your cameras. Thank you very much, all of you. And so next, well, I don't know, next quarter or the quarter after, I'm planning to do an experiment where we still have these Zoom classes like this for 2A over Zoom, but all of you guys will actually be in a physical classroom, just like a face-to-face class. Everybody will be in a classroom, but I will be on your Zoom screen rather than in front of the whiteboard out there. Now, I think that actually would actually work better than me being physically present, because then I'm going to be right in front of your eyes, whether you're in the back seat or in the front seat, and we could all interact equally. Because I always felt that the traditional model, where there's some students in the back and some in the front, is not actually equitable in a good way, because the people in the back, they can basically check out, and the instructor does not have a chance to focus on them as much as the ones in the front. So this way, I think it'll be much better. Plus, I can actually teach in multiple classrooms at the same time, right? So if you have many classes and they're all sitting in class, and I would be there that'll be so cool. That'll be so cool. And then students can switch between classrooms too, right? Oh, I don't like the professor in this classroom. I'm going to go to the other classroom and get the same professor again. All right, okay, so that'll be so cool. All right, all right, okay. Anyway, enough joking. We'll start as usual in about 5 minutes time, and use the 5 minutes to get into the right camera frame and everything, and switch on your cameras. Okay, so we need to have a good presence, a audio visual presence for everybody, so we can continue with our coding. Obviously, before we start coding, I'm happy to answer any questions you have. Meta questions. Meta meaning not directly related to coding, but uh, related to coding in an indirect way. So any questions, right? About class, about the midterm, about how to prepare, not just for this class, other computer science classes, like follow-on courses, other things you can do, and other subjects, anything, right? Anything is up for grabs right now. So you can ask any questions you want, or you can just talk amongst these with your own classmates, and talk about you can talk to your classmates about what each of you are planning to major in, whether it's data engineering or game development or machine learning, or there's so many different fields, right? Or just research, or applied computer science. So you can talk to each other and say, obviously, not everybody's going to major in the same field. Different people have different interests, but they all want to do it with computer science. So that is the cool thing about this class. Okay? So you can talk to each other about that and get some ideas. And hopefully, these ideas will also stick around and with you when you do my 2B or 2C, or anyone's 2B and 2C. It's good to have found these ideas, because then you can approach your more advanced classes with that in mind already, saying, well, you know what, I want to do this eventually with computer science. So in this course, these are the areas that I want to focus more on. So it always helps to have an idea of where you're going as you're moving, right? Because if you start a journey without any idea of where you want to end up, and you just end up meandering here and there, right? And eventually you may find that I want to go there, but I ended up here. Now I got to go all the way. Whereas if you already had an idea of where you want to go, It's okay even if it's incorrect, right? Even if it's incorrect, you would be able to change course along the way. But if you don't have any idea what you're doing, I'm just going to do this because, I want to get a job like everybody else in the Silicon Valley and get a six-figure salary or something like that. Yeah, okay. A very loose goal. Okay, very loose goal doesn't really get you anywhere, because you can get a six-figure salary doing anything. And why this particular thing? You need to know why this particular thing is important. Then you'll be able to chart a course much better. And that is why. And always, I am for a long time I've come to the belief that history is actually useless. Well, I don't mean useless in that way, but useless in the sense it is very little use to think back and reflect and saying, well, I should have done that, I should have done this. I did this 5 years ago, but I should have done something else. Oh, well, yeah, that's all gone. You can't go and change the past, right? So it's better to just say, well, you know what, this is where I am now, and this is where I want to go. So I'm going to change. I'm going to change these things. Looking forward actually makes even I think even when it comes to great civilizations and huge political battles in the geopolitical arena, right? History is less. People always say, I got to study history because I can prevent myself from doing the mistakes that other people have done. That is all bullshit. Okay, history is just a way, I think, of making yourself feel better about yourself, saying I'm special because I didn't do all these things, or I'm not going to do all these stupid things that other people did. At the end of the day, that's all nonsense, right? All we need to do is just look objectively at each situation and say, what do I need to do in order to do the best in this particular situation, right? So if you have any trophies or great things that you've earned in the past, well, okay, it was great when you got it, but after that, it's useless. You might as well toss it, right? If it's not, if you can't eat it, you might as well toss it, right? So you only look forward. And I think that is a better approach to handling all of the challenges that come our way. All right. So obviously that's just my opinion and could change at the end of class. It could change depending on what you guys say too, right? So it's just what I feel at this moment, and I just say these things. So you should never take my word for anything I say, even in C++, right? I can say, don't use size T there, okay? And you say, well, all right, well, I'm going to use int because professor told me to. But you go start working and say, well, no, int is a bad choice. You should have used size T. Okay, well, that was wrong. What Anand said was wrong. So I'll use size T. So never take anything that anyone says as though it is the ground truth, unless you check it out with your own mind and say, well, is this the real truth? Can I find out, does it actually serve me well? Does it serve the world well? Does it do the right thing? And people think I'm going to follow someone else because I can't find out what the right thing is. Someone else has done some deep thinking and found the right thing to do, and I'll follow what they said. That's like total nonsense, okay? And you'll end up just being a follower all your life. No, I don't think that it is beyond anyone to discover the right things themselves. Just needs to sit down, right? Most of the time, especially people in your age bracket, they convince themselves incorrectly that they cannot find the right thing to do, and that is because at your age there are like trillion things you have to do, right? You don't have enough mental cycles to do everything deep enough, and so you think, well, I can never do this so well as that person, right? So I might as well follow the direction. No, it is not. That is not the case at all, right? You'll find that anything you do, if you just set your mind to it and just get rid of all the fluff in your mind, right? So all these things that really dead end pursuits, right, don't lead to anywhere in particular. They give you these little pieces of candy along the way, saying, well, you know what, this is great, you're special and special because you're doing this. But at the end of the day, well, you are special all along, but you're not able to do this. You're a total wreck. And that is no use, right? So you got to see all the way through, right? Am I going to be special all the way? And am I also going to get the final goal, right? Then, okay, it makes sense to follow this path. Something else that says, even some, person who probably does not know the right answer, but probably has your best interest at heart, okay? But they think, well, you know what? I like that person really, really well. I need them to succeed, right? Because I'll be happy if they succeed. So I'm going to make sure that they don't go down the wrong path. And they'll tell you, don't do this, because this is a way to succeed. But how do you know? They'd never achieved that success themselves. They've seen someone else achieve the success and saying, well, I want this person to also achieve that success. So I'm going to steer them away from what they're doing and do. No. Right? Because they haven't done it themselves. They don't know. So you got to check it out in your head and say, well, is that really the right thing I need to do? And then you do it. Just follow what you think is the right thing to do. And you'll find out that you can actually determine what you need to do if you just stop following lame ass advice, right? Even if lame ass, again, I want to say lame ass does not always have to be malicious or coming from a person who wants you to fail. No, many times lame ass advice or bad advice comes from people that are well-meaning and want us to succeed, right? Because they want us to succeed, they want us to be happy, but they just don't know how, or they know, or they think they know how, but it's probably not the right thing for you, because they're thinking about your future by putting themselves in your shoes, right? Because you're not them, you have a completely different skill set, right? You may be a musician, they may be a mathematician, right? And they say, well, you know what, you don't play your violin all the day, all day long, you got to do this, you do this and do this, right? Because you see, if you do mathematics, you can be like Einstein or someone like that, right? And they'll try and force you, and because they want you to be successful, so they say, well, how can they be successful? You know what, if only I'd done mathematics like that person, I would have done great things, so I'm going to force that person to do mathematics too, right? So they put you in that and say, force you to do that. So again, see, that is well-meaning advice, but it's incorrect advice. And how do children know that, right? How do young kids know that? You got to find out, even though it's well-meaning, is it good for me? Because that person is a good mathematician, but they want me to be a mathematician too, but I'm not a mathematician, I'm a musician, right? So you got to put yourself in your shoes and say, well, this is good for me, and do it. And like that, okay, CS2A, CS2B, CS2C also, just take everything I say with a grain of salt and always check it out. And I don't have any complaints with this class, right? Even in class, when we do things and we do something wrong, one of you will basically just pipe up and say, hey, this is the right thing to do, and we change it. And that's all very good, right? And you need more of that to happen, right? And when you start working also, you need more of that to happen. When you're typing, coding with someone else or in a group, and someone says, hey, no, let's not do that, or you shouldn't do that, because that is inefficient, or it'll crash the system later on. You should basically say, well, why would it do that, or and find out really, right? And rather than saying, because that is one of the things that I find that early, beginning programmers are especially susceptible and vulnerable to, is that they come up with a cool solution for something, but unfortunately the cool solution might have a serious downstream problem, which you don't see, right? Because newbie programmers, usually they don't have vision into the entire product cycle, or or other modules that are going to get integrated with your code, right? Maybe you write 15 to 20,000 lines of code, which is going to be bundled up into a big project, which probably has 1 million lines of code. So you think that in your 15,000 lines of code, you come up with some really, really brilliant idea. And you do that, but a senior programmer comes to you and says, no, you shouldn't do that, because it causes lots of downstream problems. But I've seen lots of programmers who are so wedded to their idea because it is cool. I don't know if you've encountered this thing, right? This feeling when you do something, sometimes it feels so cool, right? That say, this is going to be, you in your bones, you will feel that this is so cool that the CEO is going to come down and shake my hand and say, wow, you know what, you've made a difference to the bottom line of our company. You'll feel that when you write some code. But then you'll have a senior programmer come in and say, well, you know what, that is actually dangerous. You shouldn't be doing that, change it. And you say, if I change that, I've lost my cool idea. It's gone, right? Nobody will see it. Not even the director will see it, let alone the CEO. Right? And I say, well, I don't want to do it, man. And you try all kinds of crazy ways to make sure that your idea is still in there. But in order to bolt your idea in there, now you've got to do 100,000 different shortcuts and mangle your code, right? And fit your idea in there in a contrived way. And that is like the opposite of what you want to do, because your code now looks awful rather than doing something cool that you originally envisioned, right? So, but the thing is, because that cool thing is so cool, people get attached to it. So here's the antidote. Okay, here is the antidote. When you start working later on, when you feel this is the and you feel that you've come up with something cool and you don't want to let go of it. Well, first of all, you need to get to the feeling, right? You need to feel. You need to get to something where you feel this is so cool, I don't want to let go of it, right? And until the CEO sees me and shakes my hand, I'm not going to let go of it. You're going to grab onto it. You got to experience that, okay? You got to experience that. But when you experience that, you got to be able to let go of it too, right? Even though you don't want to let go of it, how do you let go of it? Okay, and here is what I found in my own experience, and maybe it'll help you too, right? So the first time when you come up with a cool idea, you think that this is the coolest idea I've ever come up with. I'm never ever going to come up with something like that again. And I want everybody in the world, not just the CEO, I want the presidents of all the countries to come and look at it, okay? And recognize how cool it is. So you got that feeling, and you're not going to let go of it. right? But the trick is to just convince yourself that, well, you know what, this is cool, but this is the first of 1 billion cool things that I'm going to do. And that is true. That is true. And in fact, I realized this after a conversation with my PhD advisor, okay, a long time ago. In fact, he wasn't even my advisor, formal advisor. He was in a different university, advising a different bunch of students. And he said, well, you know what, after conference, he said, why don't you come over and spend a week in our university and play around with our code and, interact with our students, right? And so I went to that university, Waikato, right, in a different, and I was playing around, yeah, actually it was Craig Neville Manning. He was the other student he went on and joined Google later on after that, and so he had some really cool ways of interpreting PostScript files and or generating PostScript files directly from things that we were playing with, and so I. What happened? Yeah, okay. So I did something, and that was not in alignment with what I was writing in my PhD thesis, and that non-advisor advisor told me that, you know what, you should chuck it. You should chuck what you have in your thesis, right? Even if it means that you're not going to get that paper, chuck it, okay? And do it this way. You'll be happier for that. And I thought, well, you know what? That is so cool. That what I did there was so cool. If I did that, I would have lost it. But fortunately, I had the good luck of saying out to that professor what I felt in my mind and saying, well, that is so cool. I don't want to lose it, right? I want to have that in my thesis. And he said to me at that time, was it him or someone else? Yeah, all right. He said to me, look, is this the only paper you're ever going to write in your life? Right? And I said, no, this is like the first paper I'm going to write in my life, right? And they said, okay, well, that is that. There you go. You just answered your question. Forget about it, right? There's going to be hundreds of papers you may write, and unless this is going to be the only thing you're going to do in your life, why are you so wedded to the idea? Let go of it, because you'll find lots and lots of things you can do. And the moment I let go of that was when I was able to make real progress and say, well, you know what? Because I was basically stuck on, banging on a like you guys, right? And on a quest, you just banging your head and saying, I got to do this, I got to do this. Even though I have the password, you can just keep moving on, because you'll come back and say, well, you know what, I can now do this all much more easily. And I think that is the way to do it. So, hey, and by the way, they opened up the enrollments for CS2B next quarter. And I am teaching one of CS2, 2A, 2B, and 2C next quarter. But I usually try and not do 2C until spring, because there's not enough students usually to get a full class in 2C. I only do 2B, but somehow, some accident, I think, I must have asked for a 2C in winter and I got it. But yeah, okay, and it's too late to change it now. So hopefully enough people will enroll, okay? Enroll in 2B and 2C, tell all your friends. So we'll actually still run a good class. And hopefully all of you will be in a 2B. So the same class section, same section, you'll all be seeing familiar faces, talking to each other, just like now, and you'll have a great deal of fun, okay? And 2B is fun. 2B is fun. It'll be challenging, but it'll be fun. 2C is the most fun, okay? 2C is the most fun of all. And it'll be the most challenging also, and the most fun. And I hope to see all of you, okay? All right, what time is it now? 8:20. Right, we can start class. We can start class, and obviously, more of you need to switch on your cameras. Please do that. And today, I think what we can do is write some more code. Yeah, write some more code. And I'm thinking, unless you guys have an idea, all right? If you guys have an idea of what to do, well, what we want to do today is just use classes. Let's use classes. By the way, we finished last class, all right? We finished that display with effect last class. We got two different effects to go, right? The matrix effect and the rolling in effect. Now, I offered extra credit and nobody took me up on that, okay? Well, the extra credit offer is still there because we're still talking about objects. If anyone can do more special effects, like the explosion effect and all, it's actually very easy. I showed you, right? Explosion effect. Or reverse, right? Or characters just rolling around, all these, so many different effects. We're not going to do more effects, right? It's all the same. Do it and post it and share the code. I will give you extra credit for those things. Absolutely. Okay. So if you have any ideas that can use a class, classes and objects and more cool things, not display with effect. We'll do a different class altogether, right? Let me try and think of some projects that we did in a previous class. Yeah, unfortunately, usually I think about an interesting project the previous day, and I didn't do that yesterday. But there's so many interesting projects we've done in the past quarter, so I'll try and think of one of those, and we'll do that again today. That uses classes. My plan is that we'll do that today and on Thursday, and next week we'll implement a stack, right? A stack data structure. It's an abstract data type where you're going to take a really, really powerful data type like arrays, right? An array or a vector is the most powerful data type you can ever have in C++, okay? There's all these really, really sophisticated data types, trees and everything, but the array, a vector and an array is the most powerful ever, right? Data structure you can ever have, because no matter what you do, you always get constant time, right? Well, simple operations, right? Access and modification. Well, the basic operations. What do they call the basic operations in databases? Edit, delete. There's actually a word. There's a word. There's a word they use. There's edit, delete, substitute. SED. Or something like that, right? So SED operations or something like that. Edit, delete, insert, SEI. All right, so 3 operations are sufficient for all database operations, right? So you can have a massive database, relational database, so many things linked to each other, terabytes of data, lakes and lakes of data in the cloud. All of that can be reduced to just 3 or 4 operations. 3 operations, I think, right? I think it is insert, delete, and substitute. I think those are the 3 operations. If you have those 3 operations, bare minimum, or maybe just insert and delete, I don't know, right? So you can do everything you want in database. So where was I going with that? Yeah, arrays. Arrays are so powerful because you can do those basic operations in constant time. Any other data structure you can, right? And so we'll take the array and next class and make a, oh, we're already doing that in quest 8. Okay, all right. So in that case, what we'll do is next class we'll start talking about pointers. Okay, we'll start talking about pointers next class. Pointers and linked data structures, like super duper important. Okay, we'll do pointers next class. Next two classes, right? The entire next week we'll do pointers. The week after that, I think, is week 10. Week 10 we'll implement a stack using pointers, because in quest number 8 you got to implement a stack without using pointers, using arrays. You take an array, which is really powerful, and take away a lot of the freedoms that programmers get from arrays, and basically make it harder to use. Well, not harder, but you can't do certain things on the array. Then you get a stack. So we'll do that. You got to do that in quest number 8. But in week 9, week 10, we will implement a stack using pointers and allocated nodes rather than arrays. I think that'll be fun. Okay. So and then week 11, we'll do a linked list, right? And maybe a linked list and some kind of game that uses linked list. I think last quarter we did a Wheel of Fortune, right? We did a Wheel of Fortune game with linked lists, I think. Right, we'll try and do something similar, because that was fun. We never got to the absolute end of it, adding all the bells and whistles. But this time maybe we'll try and do more. Okay, because I think that every project that we've done so far in class, we've managed to get all the way to the end and also do a little bit of frills, more than what I've been doing in the last quarters. And I think partly because it's all because of you also, because you guys are all doing things maybe faster. Or maybe the same speed, but maybe I've gotten a little faster, because previously it was the first time for me for doing this in class. But then after that, I started to anticipate what students are going to do and basically just nudge you in the right direction. So maybe that's the reason where we're completing these projects in class much more successfully. All right, so that's what we'll do today. Yeah, okay, I've got an idea for what we'll do. Okay, so how many of you have already done quest number? Yeah, quest number 6. How many of you have done quest or started quest number 6 or tried to do quest number 6? Yeah, some of you. Okay, good. Right. In quest number 6, you have to create a name for a pet, right? You make a pet, and then you have to make a name for the pet, right? And it can be just a random name. Well, it is a random name, but it can be the name's got certain properties to it so that it is pronounceable. Okay, you can say I got a pet and the name of the pet is XQPKR, right? How do you pronounce XQPKR, right? And so you can't say that, but you got to come up with a name that you can pronounce. So you say, oh, this is a pet, and my pet's name is algorithmically generated. It is Xanadu, right? Okay, so it was generated by the computer. So we will we'll write an algorithm. Not to you're going to do that anyway, right? You're going to generate names by yourself in quest number 6. But today, what we'll do is take that to the next level and say we're going to generate sentences, okay, whole sentences automatically. In fact, what we'll do is, yeah, okay, all right. So here, how many of you are interested in natural language processing, or machine learning, natural language processing, that kind of stuff? Interacting with a computer using speech, not speech processing, but natural language processing, grammar and things, natural language. Or if you're interested in natural language stuff, it's an essential part of machine learning. Even if you're not in machine learning and just doing plain data engineering, you'll have to do natural language processing at some point in your class. Okay, so are you interested in natural language processing? We can do that. That project is actually an NLP project. Okay. So here's what we'll do. We will create what is called a generative grammar. This is called a generative grammar. Okay, in the field, a generative grammar is, and it's just going to be a simple rule-based grammar. So we'll just define a particular way in which sentences can be formed, and the grammar will say, well, you know what, my sentence has got to be of the form article, noun, verb, article, noun. Okay, the cat sat. Well, the cat ate the mouse. Okay, right. That way, the on is a preposition. Right, so the cat ate the mouse, right? So article, noun, verb, and so on, right? So we got these slots. It's called a slot filling grammar. Okay, slot grammar. I don't know what the exact terminology is. I've forgotten. This is called a slot filling grammar. Okay, where you have slots, and each slot has label. That slot can only take a noun. That slot can only take a verb. All right, and article and so on. So now we will generate a slot filled grammar, and then select the words that go in the slots. And once we've selected the words that go in the slots, we have a full sentence that we can print out on screen. Okay, how cool is that? I think that is really cool, and we can come up with lots and lots of interesting sentences to do. Interesting sentences that the system can generate using clever choices of these words. And we're going to use classes and everything. It'll be really cool. Okay, so we'll do that. So today, how about if someone has a tablet, right? iPad or some kind of tablet. If you can share your screen with the tablet, I'll give you a really, really brief overview of what the slot-filled grammar is, and then how we can generate sentences. We'll generate a plan, right? High-level plan, right? High-level plan, not the pseudocode, high-level plan of how we're going to generate our sentences, and then we'll translate that into code in C++ code with objects and everything. And I'm pretty sure we'll wrap up everything today in class. If not, there'll be some loose ends maybe, and we'll wrap it up on Thursday. And on Thursday, we'll have a full sentence system that can generate sentences, as many sentences as you want. And in fact, you may be pleasantly surprised later on when you're doing quest number 7 and quest number 9. Okay, in quest number 9, I generate sentences. I generate random sentences and give them to you, right? In quest 9, you get lots of random sentences to process. Well, actually, I think I generate song titles or something like that. Right, so random sentences, and I give it to you, and that's how I do it. Okay, I generate sentences like that, and you're going to do exactly the same thing I do in questing. So essentially, you'll know what happens in the back end of the questing system, right? So that's what we'll do today. I think this is what we did in a previous quarter. I think we generated sentences, but we'll try and do it slightly differently. Maybe every class, every time we do something in class, it's slightly different from the time I did it before, because you guys are different. And then you may suggest things, and we actually try and it has like minor variations. Okay, so we'll do that. So does one of you have a tablet? And only for 5 minutes. And the same person does not have to share the screen also, right? Someone else maybe today can share the screen to code. But first, if someone who has a tablet can share the screen, I'll show you what a slot filling grammar looks like on screen, right? Not in computer code, looks like on screen. And then using that, we'll code. Okay, so can someone who has a tablet share your screen, and then we'll take it from there. Okay, it's just 5 minutes, and then after that, someone else who can code. Hey, Leonardo, you said you can code today, right? Someone said they can code today. Was it Leonardo or Kenneth or Connor? No, Connor coded last class. Ken, was it you?
Yeah.
Okay. So Ken, you can code. But do you also have an iPad or something? A tablet? Anybody else has a tablet that they can do a screen share? And it also has to have Zoom, so you can fire up Zoom on it and share the tablet screen. Can you do that? If you don't, if you can't, well, that's okay. We'll just start coding and we'll do our best we can with the with the shared screen. Okay. And again, I think we can do all of that, all of today's code just in an online compiler. No need to go into Xcode or VS Code yet. Sadiq, okay. Is this an iPad, Sadiq? Great.
Yeah, it is.
Okay, cool. All right, so here's what we want to do. Let's write a very simple sentence on top, and just use your pencil or something and write the sentence. Write a sentence that has these essential parts of speech, right? The cat jumped. The cat I don't know, the cat, yeah, a cat jumped. I want to keep the sentence simple, so I don't want to say over and on and so on. Well, let's put a preposition there, okay? The cat jumped over the wall. Okay, the cat jumped over the wall. Okay, all right. So now, can people? You've got to pipe up now and share your thoughts. Someone has to tell me what are the different parts of speech here. What are the different parts of speech? What is a? Right? What is a? Is a noun, or what is it? Is it an adjective or a noun or an adverb? Does it? Do people know what? It's an article. Yes, an article. Right. So the a is an article. So let's put a circle under there, not around a. Further down, let's draw a circle on the left. On the left, yeah. All right. So and then you can say ART inside the circle. All right. ART. So you need to select an article in that slot. Right. So write ART inside that circle, inside or below. That's fine. Yeah. Okay. Inside. Okay. Now draw an arrow, another circle there. And what is a cat? What part of speech is a cat? Right. Actually, the arrow goes from article because it goes from A to cat, right? So the arrow goes from article to this circle to that circle. The arrows go from circle to circle. Yeah. All right. So what is cat? What part of speech is cat? What grammatical category does cat belong to? Is it a verb?
It's a noun.
It's a noun, right? So let's say noun. Well, Sadhvik is going to run out of colors, I think. All right. So he's using different colors for each circle. Okay. So put a noun in the red circle. Noun. Okay. What is jumped? Jumped. Come on, right? I'm pretty sure you guys know what it is, right? So you have to muster up the courage. It's a verb, yeah, it's a verb. So you guys know what it is. You just talk, okay? It's a verb. Say verb. And what is over? That's harder, I think. What is
That's
over? In fact, sorry, what is it?
A preposition.
It's a preposition. Okay, because I wasn't sure myself. Because I know because I didn't know if over is a preposition. Yeah, thank you. I thought it might be.
Sometimes it might be an adverb, but I think in this case it's a preposition. There's some that sometimes are adverbs, and it's weird. Like here and there are adverbs, but over I'm pretty sure it's just a preposition.
I see. Okay, cool. All right, great. So say preposition. No, it's a jumped. Jumped is a verb. You got to write verb. And also under verb, you say PT, right? PT. Why is it PT? Because in English, the tense of the verb has to agree with everything else, right? And well, the tense tells you whether it happened or is it happening or is it going to happen, right? So it's past tense. So it's a PT. Because otherwise a sentence won't be, right? Because if you say a cat jumped over the wall, it doesn't make sense, right? Because the cat jumps, you got to have an S, and that is, so you got to have verb underscore PT, right? Or under the verb, say PT for past tense. PT. Okay. All right. So over is a preposition, and say PP for preposition because you can't fit the word inside there. PP for preposition. right? And then another arrow, and then you're going to say article for THE, article for THE. All right, article. And then the final one is also a verb. Yeah. You say art, you said art in there, but that's fine. That's fine. Okay. The one more
The
arrow.
final one should be a noun, no?
Yes, absolutely. All right. It is a
Oh,
noun.
I thought you said verb. Okay.
Oh, I see. I see. I'm sorry. Yeah. So the last one is a noun. Okay. So put a circle for the last circle and make it a noun. No. After the article, no. That article is fine. Over the right over the wall, right? So you need the article there. That's art. Yeah. And then an arrow from there. The wall. Wall is a noun. Okay. Good. All right. Now, what you have there is something. So later on, when you study advanced computer science, you're going to learn about something called a finite state machine. How many of you are already familiar with this thing called an FSM, or a finite state machine? Finite state machine. Raise your hand if you know what a finite state machine is. All right. So Mark knows. All right. So if you well, only one person knows. A finite state machine essentially is a computer, right? Because it cannot be in continuous states, right? It cannot be in it's got a finite number of states it can be in, and in each state it can do a certain number of actions. So in the first state, the green circle, it can only emit an article. It can. So if the computer is in state 1 and you say, hey computer, give me a noun, it's I don't know how to give you a noun, man. I'm in state number 1. I can only generate articles in the state. Yes. Okay. After it generates an article, it's going to go to the next state, and in that state it can only generate a noun. It can't generate anything else. So it can be in one of a number of finite states, and after having done an action in a state, it goes on to another state. Okay, so this is a very, very simple finite state machine, because there's only one state it can go to from each state. So in other words, the probability of getting a noun after an article is 1, right? Because in a natural language, in the language we speak, the graph is very, very complex. The finite state machine is really complex, isn't it? Because after I say the, I could say anything, right? I could say the cat, I could say the train, I could say the boat, right? So many things that could happen after I say the, right? So the probability I say cat maybe is 0.001 in real life. But here we've constructed a very simple subset of this massive graph in our mind, saying, well, you know what? The probability in this state is 1.0. I'm just, after I say this, I got to go to that next state. Okay, so so this is a finite state machine. Later on, when you study computer science, more advanced concepts in computer science, especially compiler theory and things like that, you learn finite state machines, how to handle finite state machines, which have multiple transitions, right? So the arrows are called transitions. Transition goes from one state to another. You transit from one state to another, it's a transition, right? So the arrows are transitions. So when you do something, you transition to another state. You do something there, transition to another state. Okay, so this, it's got these, and so later on you'll be modeling machines where you emit something, or you perform an action, and then there's a whole lot of different actions you can do. So and then the probability that one of these is chosen is given to you, and you choose one of those based on the probability, and then go to the next state and perform an action there. So you got these multiple actions, right? So we're not going to do that. We'll just do a very simple one. Maybe we'll, if we have time on Thursday, we'll modify that to do it. For example. After verb, after preposition, after preposition on Thursday we'll try and branch. Okay, so after preposition you can go either to an article of type A or an article of type B. Why is that? Because if the noun starts with a vowel, I gotta use I can't use a I can use a, I can say a apple, right? I gotta say an apple, right? So the article there is not a, so I got an article in that state that can only be an, right? Or the, the, right? Whereas in that state, I can get the, the, right? Or a. So you got two different sets of articles. So already you got a branch from PP, you got two arrows going out. Can you visualize that? Yeah? Am I speaking too fast, or is this all, not making a great deal of sense to you? If not, we'll just jump into the coding and you'll see how this falls out of what we're coding. But I just want to give you a really quick intro to this before we start coding. Is that okay with you guys? Okay, good. All right. So this is one form of a finite state machine, one form in which the action happens inside of nodes. These are nodes, okay? These are nodes. These circles are nodes, all right? And these arrows are edges. Arrows are transitions or edges, connect the nodes. Now, one form of a finite state machine is where the action happens inside of the nodes. Okay, this is really advanced stuff. Advanced in meaning it's definitely not part of 2A, right? And this will actually be hugely useful to you later on when you go and do, machine learning, or, you don't even have to go to grad courses, right? Even if you do compiler theory and, in year 2 or year 3 of your undergrad work, you learn these things, right? Yeah, actually, you do learn these things in undergrad year 2, right? Because my daughter said when she was at UCSB, this is being taught in year 2, right? Year 2, finite state machines and computer science majors. They actually learn this. Okay, so so you need to. This will be very useful for you. All right. So now I'm going to tell you. I'm going to show you another equivalent representation, meaning there's exactly the same, exactly no changes at all. Equivalent representation of the same finite state machine, exactly the same finite state machine, except we've done one crucial change, right? We've shifted the action from the node onto the edges. Okay, but you don't have to do this, but I'm doing it because it kind of shows you two different things, and it also shows you when you code, this is what we're going to do, right? So now we're going to do this thing, and so Sadlik, draw under the whole thing, right? More to the left, draw a green circle and label it green circle, and inside the circle you're going to say 1. Right, number 1. No, not such a big circle. You still need to draw 6 circles, right? So you need to draw 6 circles like this, right? 6 circles next to each other. Start from the left. No, even then, I don't know. You can get 6 circles. No. You got to be same size as art. Little circles, same size as art. Okay, six of those. Well, you got the noun. Well, you're doing it in 2 lines. Okay. All right. Yeah, I was hoping you'd do all of it in 1 line because we just want to connect them all up. Is it possible for you to draw them all in 1 line? Thank you. All right. So further down, we'll actually get you space to draw all of them on 1 line. Yeah. Good. Right. Now let's put numbers in all of those circles. 1, 2, 3, 4, 5, 6. Oh, no. Put more space. Oh, well, okay. At least the last one. Move the last one out to a bit more. Last circle a bit more to the right. Okay, right? 5, 6. Now, here we also have a finite state machine, which has exactly 5 states. Okay, 6 states, 6-state finite state machine, same as before. However, this is what we're going to do. Now, instead of putting article inside of 1, we're going to put article on the arrows. Okay, so draw an arrow from 1 to 2, and above the arrow, write ART. Okay, now do the same thing, 2 to 3, and above the arrow, write noun. Okay, there's 2 ways in which you can generate your sentence. They are both exactly the same, and you will actually learn, not in CS2A. When you do, computer science, grammars and all, you learn that there is actually an algorithm you can use. You can use an algorithm to convert this into that and back, vice versa. There's a straightforward conversion from this to that and vice versa, back and forth, bam, 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 bam. So they're exactly the same because they're equivalent. You can have a conversion, right? So it's possible. So now this is what we're going to do. So in our program, what we're going to do is generate a let's say, all right. Yeah, okay. All right, so we will have a class inside of which you will have a bunch of states, and in each state you would generate. So first you're going to generate an article, then you're going to generate a noun, verb, and you move from one state to another. Essentially, we're going to follow that green diagram that Sadvik has at the bottom. We're going to start in state number 1, that is your main. Okay, and in main, you're going to say, give me an article. Okay, and then there's a function that will select a random article and give it to you, right? And after that, you're going to move into state 2 and say, give me a noun, right? and you're going to have a function that will select a noun and give it to you, right? And so you're going to do that in 6 state, and you string them all together using cout, right? Cout article space, left shift noun, left shift verb, left shift. All right, that's all. Right now, you already at this point, you probably have the entire program mapped out in your head, right? Because there's no complexity here other than that, right? We've talked about the entire complexity right here. We know how to do it. So hopefully at this point, you already have a high level plan of what you're going to do in the code. Yes or no, right? In your main, all you're going to do is just generate these 6 pieces and string them all together. And each piece knows exactly what it needs to do. And that's why it works, because you can go to the first piece and say, give me an article. And it knows how to do articles and it'll do it, right? Whereas if you have one state that's going to be doing a lot of different things, then it's much messier to code it up, right? Because you don't know what to get, and it's harder, the logic is harder. But as long as each thing knows what it's supposed to do and it does it well, your job is done. Because you can just say, you do that, you do that, you do that, get me everything. Now let's put it all together and let's look at what it shapes up to. That's what we're going to do. Yes? Right? Now, give me an estimate off the top of your head, how long it'll take you to code this, right? Because I think, my guess off the top of my head is that we'll probably finish this in less than a half hour, or 1 hour, and less than a half hour, and then we'll probably add frills and bells and whistles, make it nicer and cooler, and we'll get it all done before the end of class. Okay, so that is a plan. Sadhvik, thank you very much. I wonder if this this picture. Well, I don't know. Just look at this picture really hard and and burn it into your memory, because Sadhvik is going to stop sharing at some point. And then when we code, we'll just have to remember what these are, right? Article, noun, verb, preposition, article, right? So we're just going to generate these six possible things. Okay. In fact, we'll implement the first version, right? That's it depends, right? You can flip back and forth between the two, and it'll be very straightforward to do it. Okay, so that's all. We're going to start generating encoding now. So Ken, where's Ken gone? Right, Ken. So you should be able to pick up the after Sadhvik. Sadhvik, thank you so much. Okay, so after Sadhvik stops sharing your screen, actually Sadhvik's iPad screen is really cool with lots of colors. Let me maximize that for a sec. Oh, well, even if I maximize it, it's still stamp size. I don't see the I don't see your full picture. Okay, all right, cool. All right, okay. Great. Okay, so this is what we're going to do. So let's put our usual comments on top, saying right on top. You can say right on top, right? Line number 1. You can say today's class code and date, class code for November 15. And today we will write a program to generate random sentences from a slot filling grammar. Okay, that is, I think that is a technical term for it. I might be mistaken, right? It's from a slot filling grammar. Generate a program to generate sentences, to generate random sentences. Yeah. Oh, random sentences. Okay, generate random sentences. No, that's fine. That's fine. We will generate random sentences using a slot filling grammar. Okay, slot filling grammar. Right, and then on the next line you can say our grammar follows the pattern in a cat jumped over the wall. Okay, a cat jumped over the wall. Colon, yeah, a cat jumped over the wall. On the next line we can put in the parts of speech, right? And on the next line you can say on the next line you can say on the next line. No, yeah, on the next line you can say article space article noun verb dash pt, right? Verb dash pt, right? So it should be a past tense, right? Verb dash pt. And then preposition pp, or preposition, yeah, that's fine. Article and noun. Okay, all right, and then put a blank line after that, and then great, using namespace standard. Okay, now we'll do this. What we'll do top down. Okay, we'll do top down, and meaning that we'll start with main, and then when we do main, we'll know what the class is supposed to be because we know what the functionalities we'll leverage in the main are. So let's go into main. Let's go into main right now. This is slightly different from the way we did last time, right? In main, let's say we want to create a class. Let's say okay, all right, so all right, okay, all right, so we'll call this class sentence generator. Okay, so we'll say uppercase sentence, uppercase S, sentence maker underscore maker. Yeah, all right, you just remember to use snake case all the, all right, that's fine. Sentence maker. No, class names always, I start with the uppercase because I think it's a useful convention for lots of people, right? A sentence maker space, and you can call it, some variable name, call it maker, or you can even call it sentence maker if you want in lowercase maker. Okay, all right, good. Okay, on the next line, you're going to say cout. Oh, it did autocomplete to maker. Semicolon after that. Yeah. Okay. And then next line. No, next line. One more. And unindent. Go back to your yeah, there you go. And you're just going to say cout. Left shift. Maker dot get new sentence. We haven't written it yet. We're going to write it. Okay, get new sentence. Oh, and put spaces, underscores. Yeah, there you go. Get new sentence. And open close. Yeah, and then semicolon. Yeah, get rid of the space before the semicolon. And now in our methods, we're going to do random. Okay, we're going to call random and all. So let's just see the random number generator just to make sure we get different sentences each time. So go into main on line 14 and hit enter. And why is it? Did it? When you hit enter, it's going into line in column 5, isn't it? Or did you hit space there? Never mind. Okay, so type in cout. No. Type in srand. Open parentheses. And then within parentheses now, within a second pair of parentheses, you're going to say unsigned. Within, no, inside of the parentheses, you're going to put another pair of parentheses. Right? Inside, yeah. Okay. Unsigned. And then outside of the inner parentheses, there you go, space, time 0L, right? 0, no, 0, uppercase L, put it in parentheses. 0, uppercase L. It can be lowercase l, but I stylistically recommend that people use uppercase L because lowercase l is harder to distinguish from 1. That's why. Okay, semicolon there. All right, now let's go above main, and then we're going to create this class and say class space sentence maker, right? Class space sentence maker. Yeah, and then a space curly brace. That's our class definition. Yeah, enter, and then put a semicolon after the last curly brace. Put a semicolon after the last curly brace. There you go, not the last after that. All right, good. So in here, we're going to make our sentence, and we need the constructor. All right, let's start with the public interface first, because that's what we're going to offer to the user. So public colon. All right, enter. No, align public with class, right? That is one of the traditions that I like. Okay. All right, now you can indent it. All right. Now, what is our method called? Yeah, so a string space get new sentence. All right, string space get. That is our public. Open close. Now above that, let's put the constructor, right? So above that, yeah, there you go. Now the constructor does not have a signature, and no, that does not have a return type. I think maybe Ashley made that point in the Reddit post. Constructors and destructors don't return values. Yes, okay. So you're going to say sentence maker, right? Sentence maker, open parentheses, and I think that's it, right? That's it. Yeah, that's it. Okay. Now let's do the private members before public. Okay, so yeah, there you go. Say private. Now here we want a bunch of methods that main cannot call, but you can call from get new sentence. Okay, so in here, let's say we have a method called get article, right? Get article, and that should return a string, right? Get article should return a string. Yeah, and no, it should return a string. So change the return type. No, not take a string. It should return a string. So return type, but it does take nothing. So you do need the parentheses. Okay, now let's do these get methods for all the other guys we have, right? We'll do a get method for all these other guys. Is everybody following along with what Ken is typing right now? Yeah. Now, I want to make one point about these. Remember these methods we're coding right now. They're called get this and get that and get so on. Now, when you read the modules, when you read the text, or even on the internet, you'll see terminology called getters and setters. Okay. Now, these are not getters and setters. Please make a note, right? Getters and setters are different from these. So maybe what we should do is not call them get article, get noun, because it says it feels like they're getters. Can you change all the get to select noun, select article, and select? Yeah, I think that's better. That reduces confusion. Now, getters and setters are used, and I'm not going to go into great detail about getters and setters because it's so simple. You can read the modules and find out. And obviously, you can ask questions, and they're called, in the modules, I think Michael calls them accessors and mutators. Okay, accessors and mutators. They're the same for getters and setters. For Java programmers call them getters and setters, I think, right? Getters and setters are ways in which you can get the private variables inside of a class and set their values. Because if it's private, main can't access them, right? If it's private outside of the class, you can access them. But if main wants to access them, how does it access it? It can access it using these getters and setters. The getters and setters are gatekeepers, right? So main can say, hey, get me that value. And that thing that is part of the class can go and get it, right? I'm not going to go into more detail. Well, we talked about this in previous classes, so you can watch the recordings, okay? All right, so get preposition. Is that it? That's all we need? Noun, verb. That's it, right? Do we only need 4 of those? I think that's it. Article noun. All right, good. All right. So now let's now code get new sentence. Okay. So where's our we have the sentence maker constructor. Do we need the constructor at all? In fact, in this case, all right, and this is another small instructional point. You can have a class without any constructors, okay? Let's comment out the constructor, so we don't need it, right? And we'll have the compiler generate our constructor automatically, because in this class we don't need a constructor. And you can see that you can write classes that don't need constructors too, right? So put a comment before that line 18, right? Line 18. We don't need the constructor. We won't use a constructor, right? We'll use a default constructor. No, that constructor itself, you can comment it out. You can comment out the constructor. On line 18 on line 18. Put two forward slashes right there. Yeah, there you go. Right now that doesn't have a constructor. We're not creating a constructor. The compiler will create it automatically for us. Okay. All right. Good. So now let's code get new sentence. Okay. Let's code get new sentence. So go to above main. Yeah. Hit enter one more time. Now tag it with sentence underscore maker. Yeah, there you go. Thank you. Right, and then tag it. Tag it with sentence under tag it with double click on sentence maker and put that in front of get new sentence. Not that. Right click on get sentence maker. The name of the class. The name of the class should go there. Double colon. All right, good. All right. Now instead of the semicolon, put a space and then a curly brace and put enter. Yeah. Okay. Thanks. Very nice. Okay. All right. Good. Now here we're basically going to do exactly what we talked about when Sadhvik had that panel on screen. So we're going to do string art equals select article. No, string space art. No, string space art, not a string underscore art. String space art equals, because art is a type. String art equals select article. Yeah, and do the same thing. No, it's a function. You got to call it. It's a function. Method, right? Return a semicolon, enter. Now do the same thing for in fact we need two articles. So let's say string art1, and then I think we need two nouns also, right? So art and then you say string noun1 equals the same thing, right? And do something like that. Verb PT. Yeah? No, pretty sure I said Mark said something in okay. That's right. Okay, so as long I'm watching all the logs every single day, right? Even if I'm sitting on a bench by the lake, if one of you submit something, I get a notification on my phone, and I know who did what when. Okay, so I'm following all that on a very fine granularity, so you don't have to worry as long as you're putting in the work. Okay, because I recognize all of you again by face and by, this is week 7 now. I know all of you by name, face, and by student ID. Okay, so I'm looking at logs, and if you're putting in consistent effort, now it doesn't have to be every single day, but at least every couple of days you come back and try something, and it works or it doesn't work, you go back, try again, and as long as you're doing that, free states don't apply to you. Okay, the free states will only apply to slackers, meaning that students who say, well, I already know something, I'll just come back at the last minute and just knock something together. Those guys will get hit by the free state and say, oh, those assignments are not going to get accepted. Okay, when I see someone who's actually doing hard work, no deadlines. Okay, until the final exam, I will accept all your work. Okay, all right. Now all you have to do is just say return. Hey, you guys are not even you guys are not listening, right? Mark, are you guys listening to class also, because you're having a conversation? I just said something relevant to what you just said, and you're answering the same thing to someone else. Okay.
No, sorry, I didn't hear.
Yeah, okay. Well, you got to. That's why I'm saying, right? So, because I answered the question that you were trying to answer, and then you answered the same question again, which means that you weren't listening in class. Okay, so please, and besides, I don't see the chat. Nobody sees chat. Okay, it doesn't get saved. It's not on the video, so you can just ask. And in fact, if you wanted to ask that question, whoever asked Mark, you can basically just ask in the middle of our class. You can say, Ken is typing, and you can say, hey, Prof, are there any deadlines? You can ask that question right here. Okay, and perfectly okay. You don't have to ask in chat. Okay, now you can just string them all together. Say return art1 plus space within quotes. Within quotes, you gotta put a space. No, not there. art1 plus within quotes, you got to put space within quotes. Yeah, plus noun1 plus, and so on. Okay, now we're just manufacturing the sentence, and we're going to return it. You see how simple this is, right? So also so simple, isn't it? Because we can just do this in our sleep. We're just following these steps one by one, and it all falls together really nicely. Okay. Plus noun 2. Now all we need is to write those functions, right? Those 4 functions, and we're done. And we can run it and it'll go, hopefully, right? Okay. Now semicolon at the end. That's what it's going to return to main. And now we'll fill in the other functions, right? We'll fill in the other functions. Go to the line 22 and hit enter. Yeah. Okay. Thank you. Yeah. All right. All right. So let's do the first one. Select article. Select article. Yeah, and it's going to return a string. Return a string. No. We're going to define the function here. So we say string, and then yeah, we're going to define it. So no semicolon. You got to have a space and then a curly brace. Yeah. All right. So here's what we're going to do. We're going to say vector of strings, square angle bracket string, angle bracket string, angle bracket, less than, angle bracket is less than. Inside, you not left shift, less than, and in there you're going to say string, right? Close angle bracket, space, arts equals arts. No, arts equals, or you can even say articles, that's fine. Articles equals, and then open a curly brace there. I don't know, right? I don't know if we can initialize a vector like that in this standard of C++. We'll find out, okay? If it doesn't work, we'll try a different way of initializing the vector, but we're going to try it this way. Now, within quotes, say THE. And then comma after that, and then A, right? A. Those are only 2 articles, right? Because if we say and, I'm going to leave that as a challenge for you guys, right? Or we'll do that on Thursday. If you have 2 kinds of articles there, A and an, that means that our grammar is not strictly slot based, because the choice of noun now depends on what article was chosen, right? If you chose A for the article, you can choose apple for a noun, right? You can say A apple, yes? Yes or no? Right? So that has a backward dependency that is not permitted in this kind of grammar. Therefore, we can't have, and there. Later on Thursday, you can modify this grammar to have that backward dependency, saying that, well, you know what? I've chosen an article, but now I'm going to choose a noun, but the noun needs the article in order to know what kind of noun to pick, right? So select a noun and the article before you was A. Select a noun, the article before you was an, okay? So select noun will get parameterized with the article because it has a backward dependency, but we're not going to do that now because we're going to do a very simple version first without any bells and whistles. Okay, so we only have these 2. So on the next line, you're going to say no, semicolon right after that, right? Semicolon after the closing brace right there, right? So you only have 2 articles, and now you're going to say rand. What we'll do is we need to select a rand that will select one of those, right? Okay, all right, so here's how we'll do it. Okay, so no, we can actually do the whole thing in one line. I'm just debating whether we should do it in one line or we should split it up into 2 lines. Let's do it in one line. Okay, let's do it in one line. If it is too confusing, I'll split it up in 2 lines, and then you can see why, right? So just say return right there. Just return. Yeah, just say return instead of that. Just say return space. Now here's what we're going to do. Arts. Get rid of that. Get rid of what you have after that, right? Yeah, get rid of all of that. You say arts, square bracket, right? Square bracket. Say rand open close, space, percent, space, arts dot size. Okay. Did we use this pattern before in a different program we wrote in a previous class? Standard pattern, okay? If you want to select a random element from a vector, this is the standard pattern to use. Why? Because it's going to generate a random number, divide the random number by the size of the vector, and the modulus is a remainder operator that is guaranteed to be between 0 and the last index inclusive. Yes? And so now if that is going to return a random article, yes or no? Do you want to split this up into 2 lines, or this is this okay as a single line?
Semicolon.
Where is it? Where does it need a semicolon?
You just need a semicolon. No, you don't put it there.
Is it good now?
Yeah, the semicolon for a moment. Yeah, it's good now.
Oh, all right, good. All right,
Right.
great. Make a blank line after
You got the semicolon right.
I'm sorry, I was talking at the same time, Robert. Sorry. Can you say that again?
Yeah,
Everything is
I fixed it. Everything's
Awesome.
good.
great. Okay. Now I can remove the blank line on 26, and that's that function. It's done. All right. Now let's go do the other another function, right? So select noun. Noun. Okay. Now again, yeah, braces. Now put a comment on top of this function. Put a comment on top of this function, right? Okay. Saying this will return a random noun that does not begin with a vowel. Okay, because an article, the article before it could potentially be an A. All right. On the next line, you can say to do homework. Okay. On the next line, you say to do homework. Say homework, right? Modify this function to be able to handle both kinds of articles before it. Articles, yeah. Okay. All right. So that's your homework for good. Okay, now here we're going to have a vector of strings again, and this is going to be nouns. And put a whole bunch of nouns there, okay? And think of, here's your chance to be creative and funny also. All right, you got to exercise your sense of humor and come up with lots of nouns, which you don't know at this point, but you got to come up with nouns such that when the system strings them together, you'll come up with some really funny sentences. Okay, like the cat jumped over the man, or or the cat. Also, you're going to have interesting verbs too, right? So try to think up ways in which these nouns and verbs could form interesting sentences. Okay, right? No, jump is not a vector. Nouns. No, I vector. No. Oh, hey, Ken. So inside of the angle brackets, it should be string, right? Inside of the angle brackets, it should be string, not nouns. Right, and then the name of the variable should be nouns. Yeah. Okay, right. Cat. Putting a whole bunch of nouns there. And get creative. And call out some nouns that he can. Any number. Call out some nouns that Ken can type in, and they should all be nouns that don't begin with a vowel. Okay, they should all begin with a consonant, like cat. You say mouse. Mouse. You say mouse. Wall. Right. Mouse. Wall. And so on, right? Come on, guys, you got to get creative. I shouldn't be the only one who's talking.
Dog.
Boat. Maybe.
Boat. He said boat. Hey, did someone say boat?
Yeah. Is it?
Yeah,
Can
cool.
I heard? Okay, thank you. I was
Yeah,
checking.
cool. Yeah. There you go. You shouldn't just be animals and so things also great. Okay. The cat jumped over.
Can sky be a noun?
Yeah, totally. Sky is a noun. The moon is a noun, right? This is cat jumped over the moon. There's a poem called The Cat Jumped Over the Moon. No, the cow jumped over the moon. Right? There's actually a poem, in a nursery rhyme, right? Kitty nursery rhyme, English thing, right? In England, I think they teach kids these rhymes. The cow jumped over the moon, I think. And spoon, right? So something that rhymes with spoon also. All right. So yeah, go ahead. Type in a few more. Okay, get creative. Yeah, you should just let your creative juices flow. Just come up with lots and lots of nouns there, right? Han Solo. Right. Type in Han Solo there. Right. The cat jumped over Han Solo. No, Han Solo. I think his name is Hans. Hans.
That's
Yeah,
HAN.
okay.
I promise.
Is it just Han? Oh, it's Han Solo. Is it? All along I was thinking Han Solo. It's 20 years of Star Wars. I was thinking Han Solo. Right. Okay, Han Solo. All right. You can say, put more characters there too. You can say, the characters from movies. They're nouns too. And put another funny things there. Funny nouns. Right.
Goblin.
Cowboy. Yeah, cowboy. What is Morbin time? Well, hey, Robert said Morbin time. What is Morbin time, Robert? Is that a noun? All right, okay, well, I don't know. Robert wants to say Morbin time, but it doesn't matter. Okay, I think we have enough nouns. You can play with this. You knock yourselves out later. Okay, so these are the nouns we're going to be returning. Now you copy that thing that selects and returns and put it there too. Okay, and you're going to change, yeah. Now do the same thing for verbs, and then verbs should also be all past tense verbs, okay? Past tense verbs. String, select verb. Yeah, and again, we can put a comment above the function that says this should return past tense verbs only. Homework is try and make it handle any tense, right? Try and make it handle any tense. And for this is more challenging because the dependency for the verb is not the word before. The dependency for the verb is coming afterwards, right? Jumped. The cat jumped over the moon. The cat jumps over the moon. The cat will jump over the moon. Oh, wow, it still works. Okay, well, it doesn't, apparently it doesn't have to be all past tense. Have to be all past tense. The cat jumps over the moon. The cat jumped over the moon. In fact, you know what? Get rid of the PT. I'm sorry, Ken. It seems that it doesn't matter for the tense. Okay, just get rid of PT. Yeah, there you go. PT. Select verb, and then also in a variable name also has underscore PT. Get rid of the online line 46. Line 46. PT, yeah, get rid of the PT there. Okay, all right. Now, now go to select verb, and you can say, put in a bunch of verbs just like that. Yeah, thank you. That's great. Put in a bunch of verbs. Vector of string verbs equals. And you can say, what are those? Jumped, you can have jumped as your first one, right? All right, put more verbs, okay? Just don't use swear words, okay? Because who knows, we may have kids watching this video and learning C++, all right? So don't put swear words in there. Put verbs, put other verbs in there. Yeah, thank you. Yeah, there you go. Yeah, Ken's already preparing the stage for it. Okay, jumped.
So is it still
Dance.
has to be past tense?
I don't think it needs to be past tense because the verb agreement is different. I mean, the verb has to agree with transitive and intransitive rather than tense, I think. Right? So it doesn't have to be past tense. You can, yeah. Will jump is good, but it doesn't have to be will jump again. You can be will do something else, right? Will sing or something like that, right? Okay.
Oh.
That's what I mean, right? You
wouldn't
can't
it-
say sing. Sorry?
Yeah, but wouldn't it be weird if like Han Solo sing? Shouldn't it be like sings? Oh, are we putting like along with the will?
Sings is fine, but you can have a singular sing, right? So you can sing, will sing, Han Solo will sing, Han Solo sings. But if you have a plural saying many people, you can't say many people sings, you gotta say many people sing, right? So that's the agreement. So let's not go
I
down
see.
that road right now. Because that,
Alright.
already we're starting diversifying the grammar will start getting more sophisticated. And,
Mhm.
dealing with grammars get hairy and sophisticated very soon. And so that's why we got to be very careful in making sure that we have the right things there. Okay, John Will saying, go on, type in more, because we want to do this really quickly so that we can have more time to play around with the code. Runs, and then what else? What are some not immediately obvious things that you can, not immediately obvious verbs, right?
Morph,
What waltz? What is it?
morph, like MORPH.
Oh, morphs, MOR morphs. Yeah, okay. Or morphed. We can say morphed. Yeah, okay, that is cool. Scared. And maybe one or two more, and then we'll go on to the next one. Okay. So one or two more. Someone other than Susilo and other. Everybody should have a chance to come up with these things, right? Because when we generate sentences, you'll be happy. Because that's a sentence that has the verb that I came up with. Okay, so you'll be happy when a sentence is generated to see that your verb got chosen. So go on and suggest more things in there.
Drove.
Okay. Drove, yeah, okay.
Morgan.
Drove. What is it?
Studied.
All right, okay, studied.
Morgan.
Someone else said something too. I was talking. Sorry. What is it?
Morgan.
Yeah, the audio from your end, was it Robert?
Yeah.
Yeah, your audio is
That's me.
somehow. Yeah. Can you say that again?
Morgan.
I totally didn't get that
Yeah,
again.
never mind.
I think what he's trying to say is morphed. So MORPET, right?
Morb?
Yeah.
I don't know what that means. Yeah, you
Yeah.
can type in morb. Yeah, you can say type in morb, right? I don't know what it means, but maybe we'll get a sentence with morbed in there. Okay, all right. This is not normal. I think it was B, not B. Morbed. No, MORB. Oh, you said burped? So no, but morbed. MORBED is what he said. MORBED. Okay.
Just
Is that it? That's
term
all.
about destroying.
Destroyed?
Yeah, it's
Destroyed. Okay,
slang.
destroyed. Okay, destroyed. Okay, all right, okay. You can add more. You can add more afterwards, okay? Do we have everything? Article, noun, verb, preposition. We need a preposition. Okay, we need a preposition. Select. No, that's it. Oh, return. Yeah, return that, and then we'll do the last one. Select preposition, and then we can run it. Oh, by the way, you got a typo on the previous one in nouns, right? In nouns, you got a typo. Return, yeah, on line 34. Line 34, you forgot to change. Yeah. Okay, good. Excellent. Now, string, select preposition. Say over, under, on, over, under, on. I think those are the three I can think of right now. You say PPs, right? PPS equals. And then I can think of over, under, on. Can anybody else think of other prepositions?
Between. Between.
Between. Anything else?
We could do beneath, but that's all redundant.
You could do was.
Through.
Beside. Oh, you first.
Within.
Within. Yeah, okay. Oh wow, we got a very rich set now. No, within, no G. I think it's ready to run now, right? Oh, by the way, you're missing semicolons at the end of all the, this one and the previous one too. Are those the only ones we need now? Nouns, verbs, articles, prepositions. Do we have the semicolon at the end of the articles line too? There's that. Yeah, cool. Okay, now I believe that, oh, you need to hash include vector at the very top. Hash include vector at the very top. Okay, now scroll through the code. Let's take a really quick look to make sure everything is okay. That looks all right. All right. And further down. Yeah, yeah. Right, there you go. It's only 65 lines, okay? It's only 66 lines of code, and I think it should work. It should work and generate a random sentence. If you run it now, I think you will get a random sentence. Yes or no? Right? If it could break, I mean, there could be some compile time errors and all. Yeah, there you go. We got a lot of compile time errors. So let's take a look at the errors and fix them, and then we'll be able to see the output. Okay. So I'm gonna increase the font size for a sec. What does it say? Undeclared. Oh, no, hang on. Select article. Why does it say undefined reference to select article? Okay, select article here, string sentence maker. Do you have a method called select article inside of your class? Inside of your class, where's your class? Select article. Yeah, there you go. Select article, and then a string get new sentence, and then select article needs to be part of the class. You need to have the sentence maker double colon in front of that. Double click on sentence maker and double click and Control C or Command C and paste it. Yeah, and paste it in front of on line 24. On line 24. Not there. In front of select article. Double colon. Select article double colon. Sentence maker double colon. No. Get rid of the double colon there. No colon. No, just double click sentence maker. Just double click. Don't do anything else. Just double click. Right now, is this a Mac or a PC? This is a PC, isn't it? Yeah. Control C. Right now, and go on, and then paste it in front of all of the other methods too. Oh, you didn't copy it. You didn't do Control C. You didn't paste it into your clipboard. Double click. Don't click and drag. Okay, click and drag will slow you down. Click and drag will always slow you down. Drag. Okay, that's why it's called drag. It'll slow you down. Double click is faster. Okay, just double click and triple click for get into the It's worthwhile getting into the habit of selecting by clicking. Okay. Now Command V to paste it. Command V. Or Control V. How come it's not putting in your clipboard? Did you double click and then after double click, did you hit Control C? Did you hit Control C after double click? Oh, it's a Mac, Command C, right? So did you hit Command C after the double click? Double click on sentence maker.
He's saying this to copy. This did like the shortcut to copy on Mac.
Yeah, for some reason I can't hear whoever was speaking now. I can hear, but it's all broken up. So something in the audio stream between there. You just need to copy sentence maker double colon in front of all of those methods. Okay, you just need to copy that and put it in front of all of the methods. One more. Okay, I believe it should run now. Okay. Hey, the dog runs on the star. You run it again, you get a different sentence, right? You run again, you get a different sentence. The moon studied beneath the star. Okay, so there you go. So we're getting these cool sentences. Now, now you can already know when you're doing quest number 9, you'll see a lot of random sentences being thrown at your algorithm, right? Because you got to do stuff with sentences in quest number 9. Now you'll know already how these sentences come about, because in my code, in the back end on the server, that's what I do, right? Of course, the grammar is not so simple. Also, it's not very sophisticated. It's a very simple grammar, but I'm doing something very similar. Okay, I'm just have a grammar, select sentences, and that's my sentence. Okay, and that's what I do. The cat morphed beside. Oh, we don't have into, right? In your prepositions, have into also, right? Into. And then I think you'll have something morphing into something else. Okay, so that is also possible. All right. In fact, what you can do is put a loop in your main statement. In your main method, you can put a loop. Oh, a Han Solo will sing into a sky. Hey, that is cool. That is cool. Okay. Now you can in your main you can put a loop and say generate 20 sentences. Generate 20 sentences in your main. Okay. Make a loop there and generate 20 sentences. And I'm not going to talk you through this, okay, because you know how to do this. Generate 20 sentences and print them all. There you go. And you need spaces. You need spaces around the operators, and then there's an extra space before the semicolon. You can remove that too. Then it'll look much better. Yeah, on line 65. Yeah, there you go. And then spaces around the operators, less than. No, not there. The semicolon should not have a space before it. Semicolon should be attached. Yeah. Excellent. And that looks much better. Okay. Now, if you run it, you get 20 sentences. Oh, you need an endl after each sentence. Okay, you need an endl after each sentence. Okay. All right. Okay. There you go. You get a whole bunch of sentences now. Okay. Cowboy runs within the sky. The cat runs under the sky. The dog morbed beneath the Han Solo. All right. Okay. So we're getting some funny stuff here. Okay. The cowboy morbed over a cat. The moon destroyed between the boat. Some of it doesn't make sense. But for homework, a dog destroyed beneath the dog. Okay, a dog studied on a star. Okay, so some of these are poetic, right? So you can write poems starting with these lines because they totally don't make sense until you think about it in a particular way, right? So that's kind of cool. Now, there you go. I told you, right? It's not going to take a long time to do this. Half an hour, we did this. Now, here's a challenge. Now, we got a half hour, and I would like to leave this in your hands. And I'll be around like before, right? I'm going to be here. I'll just be behind the camera, right? I'll turn the laptop on to look into the yard. Can you guys, and you should tell me, right? If you can't, we'll just continue. I'll code more with you. Hey, Google, hang up. Hey, Google, hang up.
To end the call at any time, you can just say,
hey, Google, stop.
Or tap the center of the device.
Okay. Sometimes when you ask Google to do these things, because their machine learning system is still learning, right? And it learns in real time too. So sometimes when you ask Google a question, you'll get a question back from Google saying, it'll do whatever you asked it to do, but it'll say, you have multiple Google devices, you have a phone, you have this, which one of these should have answered, right? It wouldn't say which one of these devices should answer, right? Because, otherwise that's the wrong thing to do, right? Human interface design. So if it says, which device, you've got multiple Google devices here, which one should answer, right? That is the wrong thing to say. However, it'll say the right thing, right? It'll just answer first on some device. Hopefully it is the device that you asked on, and then it'll say, was this right? Is this the device that should have answered, or should some other device have answered it, right? And then it'll give you a list of all the devices you have in your home, and you say, yes, no, this should have been answered by my phone, not my Nest device, right? And the next time the machine learning system would have, the probabilities would have shifted. So the next time I ask the same question, that'll be answered by the phone, right? And I can say, hey, Google, hang up the phone, and it will actually hang up the phone, not, and those kinds of really cool things. These are interface design things you'll pick up on your own too, right? So anyway, so here's is the challenge that you guys can work on if you're interested in the right? You need to modify the noun. Yeah, just a noun, okay? Let's not mess with the verb, because the verb has forward dependencies and all, transitive and transitive. So noun, the noun is dependent on the adjective, right? The article that goes before the noun. There's two things that I can show you, okay? So one is you got to select the noun based on the article, which means select noun has to be passed the article as a parameter. So you say select noun. The article before you was the string, right? You give it a and the and so on. So the noun can look at the article and say, well, the last letter of the article is the article is a. Therefore, I got to select from this family of nouns. The article is an or the. I can select from this for. So you got to make that choice. You got an if statement and a parameter to select noun. So that is, I think, a slight modification you can do. The other thing you can do, if you're up to it, is to introduce one more part of speech. You can introduce an adjective, right? And when you introduce an adjective, the sentence form is going to be slightly different. You're just not going to have something like the cat jumped over the moon, right? You'll say the angry cat jumped over the sad moon. Okay, so both nouns now have adjectives that qualify them. Now, when you select a noun, the article doesn't matter anymore, but you got to pass the adjective, because the adjective, if the adjective ends in a noun, it's in a consonant, you got to select a different kind of noun. If the adjective ends in a verb, you got to select a different kind of noun, right? And then the adjective itself will depend on the article before it, right? Because you can't say you can say an angry fox, okay, that's okay, but you can't say a angry fox, because the angry is now an adjective. So you can't say a angry. So angry. So select adjective will need to get parameterized with the article. So you select an article based on adjective based on the article. So that is the second challenge, right? You finish the first challenge, we're making the noun conditional on the adjective, the article. Introduce an adjective now, right? And maybe we'll do that on Thursday. If we don't come up with another interesting project for Thursday, we'll do that. So do that. And if you've done that too, the next thing to try is try and inject a verb, an adverb. Okay, so the angry cat quickly jumped over the lazy fox. Okay, so now everything has qualifiers. So the noun has an adjective to qualify it. The verb has an adverb to qualify it. So now the sentences become more colorful too, right? So you can say an angry Han Solo. What do they do in teleport? Do they teleport in Star Wars? No, that's in Star Trek. The angry, an angry Han Solo lightsabered, Darth Vader or something like that. An angry Han Solo lightsabered, a bad Darth Vader or something like that. Okay, so you can get these adjectives and things like that. And then, and before the verb, you can say quickly lightsabered or something like that. So you can play around, right? The sky is the limit. So would you like to play with this code and try various things on your own for about 10-15 minutes, or even until the end of class? I don't care, right? Because on Thursday, we'll just take this to the next level. Maybe, I don't know, right? Play with it more. And I'll think of some more interesting things to do on Thursday before we start looking at pointers next class. Okay, we'll start looking at pointers next class. That's week 10, pointers. No, week 9, pointers. Week 10, stacks using pointers. Week 11 is lists and a game using lists. I think that, week 12, no class, obviously. So that's why. Unless you guys want a class, okay? I'm happy to give you a classes in week 12 also. Now, today we did a relatively short project. It's simpler. We actually managed to complete it well before class ended. Do you guys want me to do more now with you guys, or would you like 20 times? Yeah, you guys would like some time to play around with this code and, just don't care. You can break it. You can do anything you want, okay? Hey, Ken, before you do anything, just click the share button the orange share button once, okay? And then I think that's and copy that share code link right in your clipboard. I think that's enough. Or just put it in chat. And the reason I say that is because I don't know if it automatically saves your code if you just accidentally go back in history in your browser and you lose it. Can you get this back? Right? We were taking a risk really. So now you have that in your clipboard. So if you accidentally navigate away from this page, you can go back to that URL and you'll get the code back. Okay. So everything is set. You guys want to play around with this code now? Don't care about breaking it. Okay. You can break it, put it back together, break it, put it back together. The only way we learn is by breaking it many different ways. So right? Oh, this object can break like this, can break like that, break into a million pieces. You got to know every single way in which you can break. Then you'll know that however it breaks, I know how to put it back together, because every way I've broken it every single way, right? So if it breaks, I can put it back together because I've broken it and I've put it back together. And if someone else says no, it's broken and I can't put it back together, you'll be surprised. You want to take a look, think, that's not possible because I've broken it every single way and I put it back together. There's no way you can break it in a way you cannot put it back together. I want to take a look. You'll be curious, right? So when someone comes to you and says it doesn't work, you'll be curious rather than saying, hey, find someone else. Right? So that kind of attitude will start to develop. All right. Thank you very much. I'm still going to be around here. Okay, I'll be here. You can call me, but otherwise, just let me know right now if this was a useful enough and a fun enough and interesting enough project to do today that gives you a bit more taste into objects and how you can create objects and how you can use these objects and so on. Yeah. Okay. Cool. That's great. Hey, David, that light behind you is really cool. It's a color changing light, is it? Hey, what is it? Is there a brand? There's a brand called Loftek, Loftek. Is that the brand that made that bulb?
I'm not sure. I got it as a gift for my birthday.
Oh, I see. Is it solar powered? Does it charge by sunlight?
No, it actually it's plugged in. It has a battery bank that it sits on. But it does come
very
up.
nice. It changes and all. It changes colors. I like it. Yeah. So I used to have one that was solar powered, but then we just burst into flames one day, and then I haven't been able to use that. All right, great. Yeah, it's strange enough. It's just solar powered, but it had enough energy packed in that. No, that's not true. It was solar powered, but when the days are short and there's not enough sunlight, they give you an option to plug it in. And when it was plugged in one day, after a couple of years, it basically burst into flames. So I don't think it's the solar power thing, that the lithium or something in there. Okay, all right, cool. Thank you all. Hey, Walter, thank you for having my back. Just in case I did something stupid. I was, Walter's there. I can be more confident in doing crazy things because I know someone's there to pull me out. Well, not that you guys can't, but Walter's already been through this once, so. Cool. Hey, great. Thank you all. So play more. Okay. I just want to hear noises. When parents go with their kids to a playground, people think that they just want to let go of the kids and have some time on their own. No, I think personally, they're just sitting there and they're looking forward to hearing all the squeals, right? Squeals of joy, because squeals of joy are really fun to hear. Because it kind of makes you feel different, even if you have worries and things like that. When you hear kids squealing and having a great deal of fun, you tend to forget everything, right? It's like having a vacation. So that's what our teachers want to hear, right? As students having fun. So when students have fun, teachers think, great, my job is done, okay? Because otherwise I'm going to think, well, did I do a good job? Did the students learn? Oh, well, maybe I should work harder, and so on. But when you're having fun, I think that, well, I got the fruits of my labor. And so there you go. All right. So thank you all so much. And call me if you have any questions. Obviously, Walter's also here, but if you want me, you can call me. Okay, I'm going to be here. Thanks. And you got to keep talking, okay? Because otherwise I'll think that everybody's gone.
Is there something wrong with my mic? Whatever.
This is a question for me. Hey, did someone ask a question? Me a question?
No, I don't think so.
Okay, cool. Awesome.
Oh, Robert, I
Alright,
think
so
you
what
asked if there's
now?
something. What?
What now then?
I think we need to determine where to put like the if statements, just in case our articles, end in a consonant. So like, well,
Oh yeah,
not
it's
even,
it's not gonna be. Yeah.
yeah. So like n, or like if we wanted to include the verb or the noun orange, and then we wanted to use an indefinite article, we would use n orange. But I don't, so we would have to create an if statement, but I think we can create, the if statement should be fine enough. It's more where we would put it that I'm not so sure.
So basically, it needs to call the noun first, then attach a, the or an or a before it. So that means we don't really need a different variable for the, what is the thing before called? The
An
consonant?
article?
An article, there we
consonant.
go.
Oh, okay, yeah.
Yeah. So we don't need
Uh,
a variable for a article. We can just say, oh, the noun, and then we just pick a noun and then str0 it, which is like check what's the first of it. If it's like within, and then we have like I don't know, maybe like a vector a u i e o, and then if it's one of them, then it's an. If not, then we can just say random off from the article, right?
yep.
That work? All right. Let's do.
Yeah, that should work.
You want me to share my screen? All right. Let me put this into a private window.
So that should work. The thing is that only works if you want to pick between indefinite articles. Because if you want to use a definite article, if you want to use the ends in a vowel. The orange is grammatically correct. So if what you're using to determine what article you're going to use is the beginning of the noun, then any noun that starts with a vowel is going to be constrained into one form of an indefinite article. Whereas if you first pick the article, then you have more free range with your noun. So if you say a, okay, now you know that your noun doesn't have to start with can't start with a vowel. But if you first pick your noun and it starts with a vowel, and you're using the logic that I think I understood you're using, then it's gonna force it into an indefinite article. So it's gonna force it into n.
I see. Okay. So
I think it might be better to pick the article first, but
yeah, I see what you mean. So we pick the article and then
the noun
because
based
of
off the article.
So where do we put it?
Yeah, that's what I actually don't know where we would put it.
So it's an if statement. That means I guess when we call it here, right? So select article first, and then I guess we could put it in the select noun and then just say, I don't know. Is this
Oh
working?
that might make sense. Yeah.
What is fork
right.
this? Fork this. Oh, there we go. Got it. So I guess in select noun, right?
Mhm.
Okay. So we wanna if.
Mhm.
So it's the, what is the thing called? So art1, right? Yeah, okay. If art1. Wait, no. Because this thing also gets used in art2.
Yeah.
So weird. So then how do we make it work for both?
You're right. Wait, let me think. I'm thinking. Because I'm also
Hmm.
thinking even if we only had a one noun, like I'm not even there with okay, we need to pick two articles. I'm thinking how we would even create a like the condition.
The
Um,
conditional, we can just say like if art
equals
equals to be something or something that is that works with the vowels, which is probably D and N.
I think yeah,
We
if
can,
yeah, if
we
it's
can say like, oh, yeah.
yeah. Well, since we only have 3 articles, we could probably just say if article equal n, like we can just include the whole article. We don't have to do like the last character is whatever, because we only have 3 articles.
Oh, you know what? Here's an idea. String article. There we go. And then we put over here select art2. And then over here we go art1. Right?
Okay.
And then we have 1. There we go. If article equals D, I guess. D, is it capitalized? No. Okay.
It's not capitalized though. I don't know that I'd use the, because the and a
And
well
and
the
this
works with anything. The will work with anything, so that's the least constrained one. I feel like we should probably use n.
N,
Because that's because n will then force the following noun to start with
be
a vowel. And that's easy
Smart.
because it's just a e i o u.
Alright.
So we just
I think
Like
if we want to
this.
make this more robust, then we could, instead of inputting a string, then we could have like a global sentence vector and just pass that in and check the previous word in there. And then we can just add on the next word in our function. You know what I mean?
All right. How would that work then?
Yeah, so right for the select noun function there, you can change that to vector and then sentence, and then we're gonna have to create a sentence vector in the beginning as well.
Over here? So
Yeah.
this thing?
So, well, yeah, so the input there. No, that's fine, that's fine. Just the input this instead of string article.
Oh, I see. And then factor what?
Yeah, vector string, or well vector in and then you need an angle brackets string. Yeah.
Oh yeah, true.
Right, and then you're gonna do and then the name and sentence.
So equals.
No, just like the and sign. You remember that, like the
Oh, and then like
the ampersand,
this
whatever.
thing.
yeah. Everything.
Yeah,
Just no, just one. Just
but one.
Just one. Why one?
yeah, yeah, exactly. We want the location. So yeah, and then sentence.
Sentence
Cool.
like this.
Yeah, and then for the if statement, we can do sentence dot. I think it's back or something.
So so this is creating the, basically it's pulling out the article, right?
Exactly. It's pulling out the previous thing. And this way we can just pass in the same thing everywhere and modify the sentence with each function.
Oh, I see. So if I see, so we do this thing,
Sentence
I guess,
back.
like, hang on, this sentence.
No, you don't need the and sign there. That's
Just sentence. Just sentence here, like this.
Yeah, and then dot back.
Okay. Dot back.
And then quote. Yeah, great. And then we can check equals.
Wait.
And
Yeah.
and
Equals
right.
and.
That's what you want to do, Thomas, right?
Yeah, because of the and.
Oh no, an.
Yeah.
Cool.
I see. So this, we can add more article.
Yeah, not just n though, an, like the full article.
That's what we were.
Oh, the full article, but
yeah.
If
yeah,
you,
so an a, put an a there. Exactly.
Ooh,
Wait,
and now we
so
can.
I have a quick question for Nima. with the sentence implementation, aren't there multiple nouns? So don't we got to keep track of separate ones?
Well, no, because we'll just keep appending them into the sentence, right? So on the last
Yeah,
line, we're
but
gonna.
what I mean is, aren't you checking you're checking a specific location in that sentence,
Mhm.
but how are you going to check that location for two separate nouns? Because the article before one noun can be different from another, so we have to take that into account when selecting it. So I'm not really sure how you go about that. But yeah, see if you can figure that out.
The article from one noun, we'd say that again, the article.
Oh,
You're
I
saying,
see.
if I'm
yeah,
not
no,
mis-
you're saying the article, he's saying the article from one noun is
Yeah.
going to be different from that of another noun.
Yeah.
So
Yeah, what I'm
but
saying
what you
is,
might
what I'm
have is you
saying
might
is,
have like a
what I'm
you might have
saying
like
I
is,
a
if you
see.
look
confidence
at
combination.
if you look at 53 and 54, you're selecting an article and then you're selecting a noun, and what you're writing right now would work perfect for that. My only question is, when we then get to line 58 and we have to select another noun, will it
Mhm.
take the article from article 2 or article 1?
It'll just take,
That
well,
check.
I'm just operating off of like the last entry, which is going to be, the select article above that. So it's going to be R2. Like the
Oh,
sentence
gotcha,
structure is
gotcha.
all going to be based in the order of the function that we're calling in this sentence maker function.
Okay, right. So you're relying on the fact that once select noun runs, we assume that the article has already been selected prior to that.
Right. Yeah. And we'd
So
have to like,
you're assuming that we're moving through the sentence sequentially. We're not checking
Yeah, yeah.
the thing before it or anything like that. Okay,
Right.
that makes sense. Thanks for
All right,
explaining.
let's try that.
Cool.
So I guess. Hey,
Then
What
for
now
this, I
again?
don't know what the rules were there, Thomas. You want to explain?
So if if you're using this article, then the following word has to start with a consonant.
Oh.
So it would be like I don't know if it'd be noun like bracket I, because you'd be looking at the first character in the string of the ensuing noun. That has to be a vowel. So it has to be A, E, I, O, U. One of those.
Cool. So yeah, you can. How do you check the first one?
So we need to just continuously produce more RAN until it like found it, I guess. So we do like a while loop here, I guess.
I think that's maybe like a little intense.
While
You probably
true.
just filter the nouns first and then do random,
Filter the
We can-
RAN.
Yeah.
Yeah, so what we can do is we can create like a second vector that's just empty, and then we'll cycle through the first one and add the ones that qualify for our and thing. Right?
All right. So I guess it's going to be a string, right? Okay. String vowel words. Yeah, sure. Oh,
Mhm.
noun.
I'm thinking though we might actually have to make the same constraint for A, because if it just happens to pick A and we don't constrain it, it could give us one that starts with a vowel in that case. So after we're done with this, we'll probably have to do it for A as well.
Yeah, that makes sense.
Yeah, well, I guess you can make another one then. Yeah.
It should be easy enough. Yeah.
You just can't just copy paste. Okay. It's like this, and then for I. No. I can do just I, right? No one is a problem there. Size T. I equals 0, colon I less than. What's the thing called? Nouns dot size. Is this
Yeah.
correct?
Yeah.
Okay. And then I plus plus. And then we just do this. And then if so nouns, hang on. Nouns and then I and then 0 equals. Oh, we need a vowel, like a vowel. What is it called? Vector.
I think, do you need a
vector.
vector? Could you use an array? Because you know it's A, E, I, O, U. Is that where
Yeah.
you're getting?
I guess we
'Cause you
can
already
use
know
just
the
an
size
array.
of it.
Either way
Mhm.
works.
Okay then. String vowel, I guess. Vowel.
Yeah, that was good.
Yeah.
The,
A- Sorry,
yeah, A, E, I, O, and U.
E.
Should we make them strings or characters? Like, should they be in single quotes, or is it okay for them to be in double
Yeah,
quotes?
you declare this as a string, so think about how you want to put that in.
Because
Maybe
then it's
is
like
it-
comparing string with string, not string with char, maybe.
But you can compare. You can look at the first character in a string, no, and with it being a char, right?
And not care.
It's
Well,
char.
maybe we
No.
can, but let's just go
Oh.
with string for
Generally.
simplicity's sake. Is in C++, or like it nouns in something?
No, I think it should be nouns, and I don't know if it's I then 0. I think it might just be nouns 0 in the square bracket.
But then if it's a noun 0, then we're
Would that
just
not give us?
checking
Oh
this
wait,
thing,
would
we're
that
just
just be
checking
the
cat.
first? Yeah.
Yeah, we're
Give us the
iterating
give
this
us
with
back
the
the
for
first
loop.
noun.
Yeah, and then this one would be Roman cat,
Mm.
and then it's the C one. So how do I
Yeah.
say it's in the thing? It's in file. Is it just in? Or is it another loop?
I don't know. Yeah, I
Could
don't
you
know how to
explain,
check if something is the
Could you
first.
explain line
character.
39 again? I'm a bit confused how you're Xing nouns there.
No,
Which one?
that's what we're trying to figure out right now.
Okay.
So we don't know how to take a string and ascertain the first character and then compare it
already-
to another character or string. That's what
No,
we're
we've
trying to-
already got the first character. We just say like
that's the first character. Okay.
Yeah. No, how do we check if this thing is in the vowel?
Yes, sorry, I'm just confused. Why do you have why are you doing the double brackets right there with the nouns?
This one?
Mhm.
Because
I
we
think
are
it's supposed to, oh yeah.
because we're creating a new this thing was this should actually be vector, right? We are creating a new gonna be vector of string that starts with a vowel. Look, currently there's
Okay.
no vowel, but eventually, as Nemo said, we're gonna create vowel and then checking the N for the vowels.
Yeah, I gotcha. I just don't understand. On line 39, you go nouns, I, and then 0 as if it's a double vector. But on line 33, vector string nouns is just a single vector. So,
Yeah,
I'm
so-
not sure what is that 0? What is that second pair of brackets doing?
So I just looked it up, and according to my understanding, is that a string can be iterated. So if you put like string and then square
Oh,
bracket
so you're
0,
only okay. So you're only trying to
Yeah.
grab the C from cat. Is that what you're
the
trying to
first
say?
one.
He's
Oh, okay,
indexing
gotcha,
the
gotcha.
index.
Yeah.
Oh, okay, and then you're gonna use that in order to filter out the for the article, or not the article, the noun. Or using the article to basically filter out what nouns to use, right?
Yeah, exactly. What nouns to
Okay.
check?
Okay, gotcha.
So how do we check if a variable is in a what is it called? Array? Is in a
No.
Just a quick question. Have we have places to go? Like, is class over or no?
Yeah, I kind of need to go. Yeah, it's 10:05.
Yeah, class is kind of over already.
Yeah, if you have to leave, I'm sure he's fine with it, but we can let the professor know too. Professor?
Yeah, all done? All done?
They're
Not
not all
yet.
done, but it's 10:05, and just want to make sure people can head out. They need
Oh
to.
yeah, absolutely. Thank you all so much for sticking around and doing cool stuff. If you guys are, got closure with this code, that's fine. Otherwise, we'll pick it up again on Thursday and make more changes. Yeah. But in the meanwhile, take that to the next level. Play around as much as you can and share it on Reddit. Okay, saying, hey, I took class code and made these more interesting things to it, and share it. 5 or 10, 15, 20 different links that you guys share. Everything will be fun. Thank you all. Okay,
Mhm.
I'll see you on Thursday. Bye.
Thank you.
Professor, I have one question.
Yeah, sure.
Might as well. How do I check if this element is inside of a array?
Which I'm sorry.
So how do I check if an element is inside of an array?
Oh, wow. Okay. So if you want to check if an element is inside an array, you got to scan the array. You got to go from the beginning and compare each
So-
element. One.
Another if so, I guess another for state. Can I stay
Well,
here
what
and
do you want to
finish
do? What are you
this?
trying to do? What are you trying to
So
do?
I'm trying to check this nouns, which is the first word. So
Yeah.
Nemo says
First
that
letter.
yeah. So to check for so that we can say for an word, we can have nouns that are, what is it called? Starts with a vowel, and we're gonna create another one for a. We're
Yep.
going to like create an array which should actually be a string. Actually, let me change that. And then this is gonna be all the nouns that is beginning, that is started with a vowel. We put it in here, and then we just do a ran from that.
Why are you looping over the nouns? You have a for loop looping over all the nouns. Why are you doing that?
Because this is like a Nemo suggestion. We just created, so we create this vector here. It's going to be filled with all the nouns. So eventually this noun factor is going to get extended with like nouns that started with maybe an O, maybe like an orange, maybe an apple.
Yeah.
And so we want to like, rather than keep generating random words, like using the ran here, and then checking whether or not they are started with a vowel, what Nemo wants is that we isolate the nouns that started with a vowel, and then we can just have one random from that.
I see. Okay. All right. Oh, okay. All right. So I'll show you how to do what you want to do, but there is an easier way to do it, right? Just have to. We can do that next class. But the way you want to do it, essentially, you want to compare the first character of nouns to one of the letters in vowel. Okay, your second. And by the way, on line 34, a string vowel. You can just make that a string. You just make that a string. You don't have to say string vowels plural on go to line 34.
Yeah.
Yeah.
Oh, can I just
Vowels
make this a
plural.
string?
Yeah, maybe I'll show you. Because the string you can use
I
a string.
see.
Yeah, you can use a string as a
And
vector
then I
too,
can
right?
look.
Because,
Oh yes, I see.
right?
Okay.
So make that as vowels.
Vowels.
Equals AEIOU within string quotes. Yeah.
And then that's going
And
to
then
be
in your inner loop, all you have to do is if nouns of I sub 0 equals not nouns of I. Oh, I see. Select noun. Oh wow, you're getting the sentence passed in on all. You're getting the whole sentence passed in.
Yeah, this is Nemo's idea to say like, oh, we're going through it as we append more things. I guess it does make sense because the last one will always be an art and here if we are doing select now.
Yeah, it'll work, but you can certainly try that. That is not the recommended way to do it, I think. Well, it's certainly it should be tried. But you can factor it in a way that's easier and less error prone. That is more error prone when you have to pass parameters around. But going back to this, okay. So what are you doing with sentence? Here, sentence at back. Oh, I see. You're looking at the very last word of the sentence, and if it's an, you're going to pick. In fact, if it is a, you shouldn't, because an and the are the same, right? Only a has vowel nouns following it. And does not have. No, a has consonant nouns following it. A can only have consonant.
But the moon works and the star works, so D and A or D and N has the same condition.
D and A and D and N, yeah, okay. So
Yes.
That means now when you have an, you can only have vowels, the nouns that start with a consonant, yes?
Yes. No,
Okay, so
N
if
is
sentence
fine.
dot back, yeah, if sentence dot back is an, you can just return one of the nouns, a random noun, just like that. The else part of the if statement, you know that it's not an, it has to be either a or the.
Yeah.
Now you can say, I'm going to return, I'm going to return a vowel, I'm going to return a noun from another set. You can have two rows of nouns, noun one and nouns one and nouns two. Nouns one is all the verbs that, all possible nouns, and nouns two, nouns that can only follow a vowel. So if the last word is an A, in a sentence, the last word is an A, then you will only select a word from the second kind of nouns. If it is not an A, yeah, nouns underscore V maybe, nouns following vowels, or nouns following a vowel, right? Nouns.
Yes.
Nouns.
And then this one for.
Nouns. Yeah, you can say
vowel.
apple, orange.
Nouns. And so on.
And then to be consistent, you got to say nouns underscore C, right? Not nouns anymore.
Vowel.
Yeah. In fact, the first category does not need to be a consonant. I think it is a catch-all. If it is not a vowel, then you can pick any noun, I think. Yes.
If it's
not a vowel, if the last word doesn't end in a vowel, then you can pick any noun. You don't have to. There's no restrictions on a noun. Yes.
Yeah.
Can you?
And what
apple.
do you mean again?
An apple
is a vowel.
All right. Yeah. All right. So it doesn't matter. Let's just say nouns V equals apple, orange, and a couple of things. Let's start with a. You just leave it like that for now. You can add more later. Yeah. Okay.
Yep.
Semicolon. You need semicolons at the end.
Oh yeah.
Yeah, and then get rid of that string vowels equals. You don't need that.
Yep.
Now, if
so
sentence dot back equals. Yeah, you can just. That's right. Now you can just return nouns C, nouns V, nouns V.
We can use this.
That's basically yeah, the whole thing with the nouns V.
Nouns V and size, and then.
No, one more. No, there's an error. You got to fix that in inner nouns. Inside the square brackets, there's another noun.
Oh yeah, I see.
Yeah.
Also
Otherwise, you get a.
Sorry, but line 41, you also got to change since you did the underscore C. You have to do that for those as well.
This one will not yet. Just do else.
No, you don't need an else. You see that you can have an implicit else there. You can save on indentation and everything. You can get rid of that else.
Oh yes, I see. So nouns. But doesn't this mean?
You can get rid of the braces.
the braces, this one?
For for the if statement, because there's only one if.
Oh,
There's
sorry.
only one, you only have the then condition, right? So you don't need braces also.
Oh, I see.
And save one more line there.
It's nice. Okay. But then doesn't this mean that if it's it will only go from here and not this one too?
You can add those two to the top also. Yeah, for now. You can add those two to the top also. You can add apple and orange also to the first list.
Oh, I see. But then
But that is not the best way to do it. That's, because there's redundancy, you're storing the same thing in multiple vectors and all. There's obviously better ways to do it, but I'm just trying to fix that last thing that you asked me with help for, for help with, right? So this should work, shouldn't it?
What would be a different way, Anand? Maybe you could do select a random value that's the size of nouns underscore C plus nouns underscore V. And if it's more than the size of nouns C, then you go into nouns V maybe. That way you could randomize what you pick from two separate vectors. Would that be possible?
Yes, it is totally possible. The only reason I recommend against that is that if you imagine the code for doing that, that is like easily like 10 extra, five extra lines of code, and then more logic programmers have to think through and all, and more corner conditions where that can go wrong. Yes, you're right. But that is the way to think about it. The way you mentioned is the right way to think about it, saying, well, there must be better ways or other ways to do this because this is messy. Yes, it is messy. Okay, there's two vectors, there's redundant storage. There's obviously better ways to factor this so that it'll be nicer. But this is, I think this is a starting point. And absolutely, yes, you should all try and do this in place.
I have another idea, and that is to just make this just one nouns, but then continuously and then use a while loop.
Yep.
While loop to just generate random things and then keep checking them to see if it's start with a vowel or not. And then
the risk with that, Susilo, is that the procedure you described is not a true algorithm in the sense that it may not terminate at all. Maybe if you have a while loop and you're gonna, right, it may always keep picking something because it's theoretically it's not, right? Eventually it's going to pick one of the correct ones, but you don't have, you can't say that with certainty, right? You can't say that with certainty. That's why it's better to do it this way.
I see.
Yeah, but what you can do though is yeah, here's what you can do. Okay, so if you want to do it the way that you suggested, Susilo, here's one way you can do this. You just have one vector, okay, and then instead of choosing a random element, you just choose a random starting point there in the vector, say the fifth element, and start comparing the fifth element with the first letter. Oh, is that a vowel or not? Is the first letter vowel or not? If it is a vowel, then you don't pick another random one, because if you pick another random one, then your algorithm may not complete at all. However, instead of picking another random one, just pick the next one. Like, it's called linear probing in hash tables, right? Just pick the very next one. And that is also bound to be random because the first one was random. It doesn't matter, right? So you pick a random point. If that is not that is not available, pick the very next one. And what happens if you go to the very end? Then you roll around using, what is a circular array. If you go to the very end, go back to the beginning again, and you can keep doing this. You're doing a modulus. So in other words, that algorithm is guaranteed to terminate because it will eventually, it will not, it will eventually cover all possible nouns. If you keep hitting random ones, it won't go to the, I don't know if I explained it clearly enough, but that way you can make sure that your approach, the way that you described it, will also work if you don't select random nouns each time, but actually just select the next one after the first random one. And then you check if it is a compatible noun, use it, otherwise go on to the next one. Compatible, use it, otherwise go on to the next one. And you can do that in loop, the while loop like you suggested.
Yeah.
Does that make sense? Did that answer your question? Yeah. Was that the question you asked?
Yeah, kind of. Yeah.
Right. Well, I don't know. Kind of.
I guess that answers the how to make it so that the the chance of the program going infinitely disappears.
Yes, yes. Even though the chance of it going infinitely is very, very small, it's like 10 to the minus 5,000 or something like that, right? Because
But it's
eventually probability. But even then, professional
Mm-hmm.
programmers will not allow for even. One time I was in a restaurant with a friend, and a magician. This restaurant, magicians come and do magic tricks from time. They have entertainment, right? When you're eating, and this magician came, and he sat he was standing next to me and my friend, and he did a magic trick, and I was like totally blown away. And then, but before the magician went away, I said, well, you know what? I think I figured out how you do it. Because if you do it this way, you'll get it like 999 times out of 1,000. One time in 1,000 is going to fail, right? But 99.9% of the time it will succeed. And that's enough for you to make a successful living, right? A magician doesn't have to fail every single time. So, but he said something to me a very long time ago when I was doing my PhD, right? He said, no, that's wrong. Magicians will never, ever do any trick, even if it has a DX chance of failure, right? Even if it fails for one person in the entire world, magicians will not do the trick. So they'll only do a trick if it is guaranteed to succeed 100%. How cool is that, right? So like that, professional programmers, they will not write code, even if it has a very, very slim chance of becoming infinite loops. If they know, right? Obviously, we write it all the time without knowing. But if we know it, we try to avoid it.
I see. Okay, thank you.
Did he say why he had that rule, Anand? Was it because if it's not consistent, it's not magical? Was that the
No. He said no. He said that magicians don't take any risks, because magic as it is, you can have things go wrong all the time. But if you want to inject a known risk into it, he said it's not worth it. It's not worth it. And besides also, it's just like programming, just like music, magic also, right? One of my friends, Adam Chire, he's actually a professional, well, not a professional magician. He actually made Siri and sold it to Apple and all. But he got into magic big time, and he's now touring and performing magic shows and all, right? I was going to say something about him. What was the question you asked, Walter?
With the why he chose to not have any chance of failure in the tricks, and if it's inconsistent, is that why it's not considered magical?
Yeah,
We're talking about if you're a
thanks.
musician or if you're a coder and the similarity.
Yes, the thing that I did remember something that I wanted to say, that Adam told me once. Maybe it'll come back to me. But certainly it is because they don't take any chances. They absolutely don't take any chances at all. They'll only do it if they know for sure. Yeah, just like practice. It's practice, just like music and programming. Got to do it repeatedly over and over again. Yeah, that's what Adam said. He came over when I did my cloud class. A couple of years ago, I taught AWS cloud, so at that time, my students did a project, and I asked if Adam can come over and talk to my students. So he came over to Foothill, and then he was talking to my students, and he did some magic tricks for them. And I think he mentioned this to the students. And he said, it seems like it is so simple and just magic just happens, but that's not true. He said every single thing that I did, which seems like I do it in my sleep, I have practiced for hundreds of years. Well, not hundreds of years. He just practice again and again and again until such time as it just becomes natural to you, right? Just like music, right? You say you hear someone play, you think that, well, they can just close their eyes and play it. It's so simple for them. But when you try it, it doesn't work that way. And you say, I'm never going to play it like that. But just practice, okay? Practice, practice, practice. And after a while, it just becomes natural to you. Yeah, and you can just do it. And that's the time when, professionals actually take that to the stage. Yeah. All right. Thanks. I hope I answered all your questions, though, Susilo. You good?
Yep. Yeah. Thank you.
Awesome.
I'm going to share this on
Please do
Reddit
continue to
later.
share. Yeah. Please share on Reddit and keep the conversation going. It's all great. Okay. All of everything that you guys are creating on Reddit will come back to benefit you in a big way later on. Okay. You can basically just point people to saying, what, that is me. That is me. That is when I started to learn C++, right? And look at the kinds of questions I've asked and things I've done in class, because all of that is not Previously, it was all on Canvas, it'll disappear, and students have no way of showcasing cool things they've done. Now this is public and it's out there. You can do it.
Yeah.
All right. I'll see you on Thursday. Thank you,
Yep,
guys.
see
Thank
you.
Thank you.
Bye.
Bye.